Okay, when you come up upon your screen, first thing I'm going to need to do is take off this driven sheave. This is the locking hub assembly, which we spoke about in class. This one here, as you can see, has been loosened up just so that we can take it off with ease in the demonstration. But basically, this locking assembly, remember to check your mark for your eccentrics. They need to be lined up between the two bolts here and here.
The driven sheave is locked to shaft number 1 by means of a tapered hub locking assembly. The locking assembly is bolted to the sheave using socket head cap screws, which clamp the locking assembly tight to the shaft as the screws are tightened. The sheave is removed by loosening all the cap screws completely, removing 4 of the cap screws and threading them into the 4 empty holes in the locking assembly. As these 4 pusher bolts are tightened evenly 1/4 turn at a time, the locking assembly will expand and release from the shaft. Slide the sheave off the shaft.
Next, you take off your seal. This here is your grease seal, your labrus seal. You want to take it off first, then you want to take off your seal plate on the side of the gear case. Normally these are bolted on, but for the purpose of demonstration, as you can see, we unbolted them. This is your basic gear side setup. What we want to do now is we want to untime it, basically, is what we're going to try to do. What we want to do now, first off, is bend this tab up on this keeper pin, a keeper bolt here, bend it up out of the way. Then you want to remove that bolt. Now be careful in doing that, because the only thing that holds that gear in place are these weights on both sides. As a sandwich by these 2 bolts here, sandwich that weight on the disc plate and hold the gear in place. Now, what we're going to do now is we're going to loosen the bolts on the weight assembly here, which will allow everything to drop down to a natural free position. Keep your hands out of the way at this time, because everything does move and it will hurt. Just like that. See how that loosened up? It was allowed to slide down. This is where your keeper bolt was up here now. This is your marks for setting your timing. Everything is slid down into a natural position. Okay, first thing we're going to do is we're going to go ahead and take the weight off on this outside. Remember, there are dowel pins that hold that in place. Plus you have your plug weights that are sitting on the inside here. These dowel pins run all the way through, clear to the backside weight. They kind of basically line everything up for you. When you're taking those bolts loose, be careful, because those things can be filled with oil. Well, they should be oily, and they will slide off. Next thing we want to do is we want to pull our gear off. Now if you do that right, it'll just slide off like that. 9 times out of 10, if you cock it just a little bit, you're going to fight it. So put it back on, get yourself square, and try to slide it off. But when it works right, it works just like that. It's real easy. Next, we're going to put the weight back on. Okay, at this time we're going to go ahead and pull the locking assembly out of the center of the hub. Remember, that's torqued down to 65 foot-pounds. This one probably isn't, because we've been working on it. Remember, the key thing when working on anything, heavy equipment and whatnot, you know it as well as everybody else, but you can't stress it enough, be safe. everything is big, everything is heavy, and they will hurt when it drops on you. Don't get your fingers in anywhere where they don't belong, and just by all means be careful.
To remove the two-piece locking assembly, loosen the Allen head screws and move 4 screws to the pusher holes. Alternately tighten the screws in increments of 1/4 turn to release the locking assembly. To remove the 3-piece locking assembly, loosen the Allen head screws and move 6 screws to the pusher holes for the front ring. Alternately tighten the screws in increments of 1/4 turn to release the front locking ring. Move 4 screws to the pusher holes for the rear ring. Alternately tighten the screws in increments of 1/4 turn to release the rear locking ring.
There are a couple bolts left in to keep the assembly in one piece. These are put it into the tap holes, and then we're going to tighten those down, which will actually pop the locking mechanism out and loosen it up so we can take it off of the hub and off the shaft. Now remember, that locking assembly is the only thing that holds that hub to the shaft. So once you break that loose, the shaft is free in there on this side. Okay, the reason we put the weight back on is because there is another weight just like it on the back side, okay? And it's only held on by the dowel pin only. And these bolts go through this weight and actually are tapped into the weight on the back side. And so in order to hold everything together for the purpose of safety and everything else, we put those 2 bolts back in so we don't have everything falling apart and coming out and dropping on your toes. And as you see, as Ron screws those bolts in, it pushes the locking assembly out, which disengages it from the hub. What's that question? Is it tapered where it goes in? The question is, it's not tapered at all. We'll show you here as soon as we pull it out. Screwdriver. This is the 2-piece locking assembly that we passed around in our class the other day. This is what you're looking at. We left some of the other bolts in, basically, to hold the thing together. And basically, that if we'd loosened them up just a little bit more, it would have slid out. But we had them too tight. I can say that now because I got it in my hand, I can see it. But that's what holds that hub, bearing, cartridge, and all that to the shaft. Now we're going to take the hub off. Got it. And we're going to expose the AN nut and the bearing. Okay, now at this time we have to go to the back side and we have to pull the backside hub off. We don't want to pull the locking assembly off at this time because all we're changing, basically, we're going to just loosen the shaft so it slides back out of the way, give us some clearance so that we can take this piece off. So what Ron's doing now is he's taking the outer hub and leaving the locking assembly on the shaft. So then all we have to do is just push against the shaft and it'll, like that. And it drops back out of the way.
On the impulse side of the screen, remove the bolts retaining the hub to the disc. Do not remove the impulse side locking assembly. From the gear side, push the drive shaft into the spindle to give clearance to remove the gear side bearings.
Okay, now at this time, we're going to go ahead and pull the bearing off. First thing we got to do is bend the tab on the we want to bend the tab on the retaining washer here, get it out of the way, then we're going to knock the AN nut loose. Okay, you want to back it off just a little ways. You don't want to take it all the way off because what you're going to do next is you're going to push that bearing off of the spindle using a grease gun. On the inside here, you can see we already have a grease fitting put up in there. In the class, we showed you how that grease zerk is put in there, and there's a channel cut in to the backside and up into the center area of the spindle. And when you pump on that thing with grease, it pushes the bearing off just like that. What we normally do is, like Ron was saying here, most times on the smaller screens and whatnot, that grease fitting and the grease pressure will work to push the bearing off. A lot of times when you get into your larger screens, what you got to do is you got to put pusher bolts in these two holes here and here and apply the pressure on there. Put your grease in here. Sometimes it'll come off, sometimes it won't. Sometimes you have to come up and you have to just put a little bit of heat, not much, just a little bit of heat on the inner race. You don't want to heat the bearings and you don't want to heat the disc. You just want to heat that inner race just enough for it to expand, so the pressure of the grease combined with the pressure of the puller bolts should pop off the spindle.
For this demonstration, we are removing and installing the wheel assembly without the aid of the wheel assembly lifting device. While it is possible to remove and install the wheel assembly without using the wheel assembly lifting device, it is much easier and safer to work with the wheel assemblies while using the lifting device. Mount the wheel assembly lifting device to the wheel assembly with 2 bolts. If the wheel assembly is lifted without the use of the wheel assembly lifting device, the bearing can fall out of the wheel assembly. Attach a hoist to the lifting device and take up the slack in the hoist. Remove the AN nut, lift the wheel assembly free of the spindle, and place it on a bench.
Now as you look as this disc comes out, you can see that there's a weight on the back side that looks identical to the weight on the front side. This is the point we was trying to make before. The weight on the front side has 2 bolts that are threaded into the weight on the back side. That's why you want to put them weight back on and put the bolts back in, is for safety's sake, so that thing doesn't fall off of there. All there is these 2 dowel pins to line everything up and hold it in place, other than those bolts. If that bearing is centered, it'll slide right out of there just like that. If it's not galded, if it's not spun, if there's no damage, if the disc isn't egged, that thing should be in there square. You should be able to just lift it out of there. Going back in, it's the same thing. When you go to put it back together, you want to set the bearing down in there, check the bore on the disc, make sure it's not collapsed, not egged. Check your bearing, make sure it's clean, there's no galding, no spalding, anything like that. When you set it back down, make sure it's square, and it should drop in the same way it came out, easily. Okay, here's your spindle. As you can see, here's the grease groove that we greased here, which applied the pressure, which pushed the bearing off. Basically, that's the initial tear down. One thing to remember is your eccentric spindles. If you notice on these, they're marked. Some have an E on the top, some have a mark on here. This has both. You want to make sure that your eccentrics are in the same position when you put it back on, if you have to remove the spindle, as the previous one was. So if on this one here, if your E is top dead center, make sure that when you put your new spindle back on, it goes top dead center. Make a note of that. Okay, make sure you mark your cases. And as we talked in the classroom, by rotating that one way or the other will determine how much backlash you'll get on your gears later on. But basically it's on the outside ones that you're doing. You won't never change this one, but it will on these. This is one here will change your backlash, but like I say, this spindle is set up the same way, but you always want it top dead center. What we'd like to do now is we're going to take our feeler gauge and we're going to check our unmounted clearance on our bearing before we put it in. Ron says we got 7,000s.
Refer to the table in the operation and maintenance manual that lists mounted and unmounted bearing clearances. If the measured unmounted clearance is outside the listed allowable unmounted range, the bearing must be replaced. Record the measured unmounted clearance for future reference.
Now, if you watch, now as Ron sets that bearing on her, he wants to square it up. And basically, once it's centered, it'll drop down in. You want to keep your fingers out of the way. It will take your fingerprints right off of you. Okay, now we went ahead and wrote down the unmounted clearance on the disc, and so we know basically how much we've got to take it down. So another thing, make sure you clean everything up, wipe it down.
For this demonstration, we are removing and installing the wheel assembly without the aid of the wheel assembly lifting device. While it is possible to remove and install the wheel assembly without using the wheel assembly lifting device, it is much easier and safer to work with the wheel assemblies using the lifting device. Mount the lifting device to the wheel assembly with 2 bolts. If the wheel assembly is lifted without the use of the wheel assembly lifting device, the bearing can fall out of the wheel assembly. Lift the wheel assembly and align it in front of the spindle. The center plug weight hole should be straight down. Before installing the center wheel assembly on the gear side, rotate the gear so that the center notch, stamped 45 degrees, is in the 3 o'clock position. Carefully slip the bearing over the spindle. Do not bump the spindle threads. Use a pliers to break off the used locking tab from the bearing lock washer. This ensures that only a tab in good condition is used to lock the AN nut. Install the locking tab and AN nut. Remove the wheel assembly lifting device. As the AN nut is tightened, the bearing is locked tight to the shaft and the bearing clearance is reduced. The final bearing clearance can be calculated by subtracting the maximum and minimum reduction in clearance from the measured unmounted clearance recorded earlier. Refer to the operation and maintenance manual for further explanations on calculating bearing clearances. The AN nut can be tightened using a bearing lock nut wrench. However, Cedar Rapids recommends using an AN nut with 8 jack screws to set bearing clearance. This jack screw AN nut can be purchased or one can be fabricated with instructions available from Cedar Rapids. Remove the AN nut and install the AN nut with jack screws. Snug the nut up against the bearing.
Okay, once we get the disc assembly on, the bearing slid up on the spindle, you want to put what we use is a jack screw setup. Yeah. Take an AN nut, you drill it out, put 8 holes in it, put grade 8 bolts in it, and then you screw it up there till it just about touches. What we're doing now is we're just running the threads in till they come up against the bearing, okay? Once everything is touching and everything is square, then we start at one point and we go all the way around, just a little bit each time, a little bit here, a little bit here, a little bit here, a little bit here. And what you're doing is you're walking the bearing up on the spindle. Okay, you don't want to do too much. You get it up, maybe do 1 lap around, then check for your mounted clearance. How much crush, how much slop has been taken out of the bearings. That's what's called your mounted clearance. And most generally on most of your bearings, you're taking out about 1/3 of what your unmounted clearance was. So if you've got, say, 7,000 was our unmounted clearance, we're going to take it down to about 4. Ron says we're already down to our 4,000s clearance. Okay, now that's pushed up on there, so it should stay. At this time, you should be able to back your nuts up, you back the bolts off the AN nut, take the AN nut off, put your lock on there, and put your other AN nut, your regular AN nut, back on there, and tighten it down. time you take this locking ring off of there, this keeper ring, the one tab that you used, you want to break it off. So the next time you have to use a new one each time. If you don't, what happens is the same thing as this keeper up here. If you reuse it, there's a tendency to break off, and then you got that in your system. It's picked up by your gears and the oil, and next thing you know, you're putting in a new set of gears and bearings.
Before proceeding, recheck mounted bearing clearance and adjust if necessary. Squirt oil between the bearing rollers to prevent dry starting.
In the classroom, we showed you the pictures of the two different hubs, okay? The difference between the two hubs is what? The lip up here. The longer is on the gear side. This is your fixed side. This is the side you want the bearings to push up upon. And that's why you have a longer pilot here than you do on your impulse side. So always the longer pilot goes on your fixed side, which is your gear side. Okay? And when you put this together, you want to remember to Loctite these bolts with 271. 271 Loctite. Now we're not going to put all the bolts back in because it's going to take too much time and for the purpose of the demonstration. Okay. Now at this time you want to go to the back side. You want to push your shaft back through and do the same thing by mounting the hub onto the disc on the back side. Just like that. Now we don't have to align the shaft because we never took the locking hub off of the other side, so it's attached to the hub. So all he has to do is push the hub up, get it flush, line up his holes, tighten it down, and the shaft is in alignment. Okay, now at this point what we want to do, you want to loosen up your weight assemblies because we want to put up your lineup bars. Be careful doing this, remember, because I showed you earlier, the only thing holding these weights on right now, once you loosen them bolts up, is those two bitty dowel pins, and that's it. Those little bitty dowel pins is the only thing holding that assembly. So you want to be real careful doing that. This is your alignment bar. What this alignment bar does is to make sure everything is aligned properly. Okay. That makes sure everything is set directly in line with each other for timing purposes. Now we can go ahead and put our locking assembly, which has to be cleaned, very clean, and then you put a little bit of 680 Loctite on the outer surface and the inner bore surface. But you want to make sure this thing is clean. Now you want to take the bolts that you put into the tapped holes out, and you want to put them all back into the outer ring where they belong, and then we'll start our tightening process. Okay, now when you start tightening this assembly up, remember this is a crucial part of this operation. You want to start off at a very low weight, say 20 foot-pounds. And then you start with your star pattern. This is a long, tedious operation, but this is the most critical, so you need to spend some time on this. Can't just grab the air gun and stick it on her and run them up, because she'll do more damage than you can imagine. Remember, we're only doing about 20 foot-pounds to start. Okay, once you've gone all the way around at that 20 foot-pounds, what you want to do now is you want to take a brass punch and just give a little tap on top of the Allen head bolts. And what you're doing now is you're trying to line everything up, take the slop out of there, using the same foot-pounds that was on there originally. Make sure with your torque wrench that all the bolts are tightened down. So you've taken all the slop out, you've given it a good hard jar so you can take all the play out of there, and then you check it again, 20 pounds all the way around. If you're good, you move up to your next weight. Okay, after you've gone all the way around, again, one more time, take your brass punch and your hammer, give it a jolt, just to make sure, and there's no more play, no more slop in there, everything is square. Check it with your torque wrench, and you move on up to your next level. You want to do this, say in increments of 10 pounds or so, 15 pounds, or maybe 20 pounds, but just keep doing it each time. And then after you've done with it, give it a jar, whack it with a hammer and a brass punch just to make sure everything's tight. You want to work your way up to 65 foot-pounds is what you're hoping to end up with when we're all done. Like I say, it is a long time to put all this together, to do it all, but this is the most critical aspect of this. All 7 of these locking hubs go on the same way. So this is a process that has to be repeated each time on each spindle, on each hub, and on your driven sheave on the outside here. Okay, one more time. Then check it. Make sure nothing's moved, everything's centered, everything's tight. You know for sure now because you've jarred that hub and nothing's moved. Now you're tight. Are there any questions on this part? This is the most critical aspect of putting this screen together as far as the hub and the bearings. You got to make sure that's locked on there tight. The bearing runs on the spindle. The only thing tying the bearing to the rest of it is that locking mechanism. Now Ron likes to mark those just like that. This way, if you have problems with your screen and it starts doing funny things and starts dancing around, you pull it down, drain the oil, you pull it down. First thing you're going to look for is that thing lined up? Is it straight up and down? Has it slid? Has it moved? If it's done that, then you're out of time. Okay, now at this time we can go ahead and remove the alignment bar. Be careful, those weights can slide off. Okay, at this time I want to put our center gear on. Now remember, when you put this thing on, you've got to line up these marks. You've got a mark here, and you've got your 45 degrees stamped in here, and you've got a mark on the other side also. That will line your gear up. Okay, you put your plug weights back in. Bring your weight assembly down. And it should all slide together like that when everything's aligned. Okay, now these bolts, you want to Loctite these in with 271. Okay, now we can go ahead and tighten down these weights on the two outside ones. So we want to leave our middle one loose so we can set our timing. Okay, now those weights have pulled together on the disc, and they've held these gears solid now. Now these gears won't turn. Now we take our timing tool, and you're going to stick it in those holes. Okay, you want your keeper bolt with new tab, and as he rolls that around, wherever you want to stop it at, say 45 degrees, then you put your keeper bolt in. Okay, and as he backs off, it'll all come into position. Remove your timing tool, slide your bolts back in. Now you can lock it down. Okay, keep your bolts in there. The gears, the weights have come together. They're tight, so you run your keeper bolt around to where your tabs should be. Remember, on this one, you want to put a new tab on. So when you run that down, you can spin your tab into position. Then you bend that keeper over. And then you weld right on the nut in the flat spot. Right here. You don't weld it to the gear. You don't weld it to the disc. You want to weld the nut to the flat to the keeper there. Okay? Now you want to check your backlash. Make sure nothing's changed. You want to check backlash on both sides to make sure you don't have a problem with somewhere else. How much backlash are we supposed to have a minimum of? You remember? 20 thousandths at least. Why do we have 20 thousandths backlash in there? Who could tell me? Okay, heat expansion is one. What else? Proper mesh of the gears is another. What else? What about the flexing that goes on in there? So you have to have a minimum of at least 20 thousandths. You can have upwards of 25, 27, even on sometimes up to 30. It will be noisier, but at least a minimum of 20 thousandths backlash on both sides. Not just one side, but both sides have to have 20 thousandths. If you don't have that, you're going to lock this thing up and you're going to shell those gears out. Are there any questions on this aspect? What do you do when you don't have 20 thousandths backlash? Then you got to start all over again. If you don't have 20 thousandths over here, what are you going to do? You got to take this assembly apart, get down to the spindle, which is down at the bottom, then you have to rotate it in order to get the clearance that you need. If you're within 2 thousandths and you want to, and say you're at 18 or 17 and you only need about 2 thousandths, 3 thousandths to get up there, you rotate that spindle with the eccentrics. There's a picture of it in your book that tells you the different hole patterns. You rotate that, one hole will get you about 2 thousandths more backlash. Then you reassemble everything, just like we've done here, put it all back together, check your backlash one more time. But if you haven't moved your eccentrics from the beginning, you shouldn't have a problem with that. But if you lock up a bearing on one of those spindles, you'll have to remove the spindle, and you'll have to make sure the eccentrics goes back in the proper place. Yes, sir. What's that? No. The question was if we have to do it on both sides. No, just on the side, which the spindle is, or where your backlash is needed. So if you need more backlash on this one, you want to do it to this one here. If you need more backlash on that one there, you'll take that one down. Any other questions? How much is one hole back? There's a figure in your book. It's about 2 thousandths, if I remember right. It's 2 thousandths per hole, and they're marked in your book. They give you a diagram so they can tell you which way to go. There's A, B, C, and D, and whatever slot you move to, that's how much more backlash you're going to obtain by rotating that eccentric spindle. Yes. No. Why? You don't have to do the spindle on the other side. There are no gears on the other side. The only gears are on this side. This is your fixed side, and this is your gear. The other side is an impulse. That's why we have to have a minimum of 20 thousandths, because there's flexing action in there. It's a spherical bearing, so the bearing will align itself. Make sure it's clean. Make sure you got all your tools out of there. Make sure you're ready to button it up at this point. You want to check, make sure it does move. Okay, at this point, you drag out your cover. You want to put your silicone all the way around. Make sure the bolt. Make sure you get a good seal with that silicone. Make sure the area is clean. Make sure your cover is clean. Put your cover on. Make sure you put in all your bolts before you tighten anything down. It's just like a oil pan cover. If you tighten them down as you go, you're going to get 1 or 2 bolts that you won't be able to get in, so then you got to go back and loosen them all up again. So make sure you put all your bolts in, get all your nuts on there, and get them locked down after you get them all on there. Now we're going to put the seal in. On this particular one, remember, your lip seal goes to the inside. It doesn't push out. It's to keep the oil in. Now these are siliconed and put on. Like Ron and I both, we use a feeler gauge just to get the lip up over the race, the seal race. And so what you're doing is you're running that feeler gauge around, lipping the lip up over the seal race so you don't cut it. And applying pressure with one hand, rolling it around with the other. There is some movement in the shaft, and you want to center this seal on there. Okay, so what we normally do is we take this outer Labra seal assembly, we take the grease fitting off, and we use it as a guide because it'll fit just inside the lip seal when it's positioned properly. That whole assembly will slide up or down depending on which way it has to go. And just push it in, and that aligns it up. And at that point, once you've got it slid in and centered, then you want to tighten your bolts down on the outside of the rings.
We don't want to tighten these down.
Okay. Then you take it off, flip it around, put your grease fitting back in, slide it up in till it touches, and then back it off to where you're flush, creating a cavity inside there. Remember, this is a labyrinth grease seal. Okay? So you want to back it off to where you're flush on the outside, and you've got just enough space for the grease to get out. Then you've got these little Allen keepers all the way around that'll lock it onto the shaft. Okay? And then the first thing you do at that point is you grease it. Grease it. So you got a wet slick of grease going all the way around. Okay? Once you've done that, then you're ready to put on your driven shiv. Okay, now this one again, you want to Loctite this on there. So it's the same locking mechanism as we used on all the shafts and all the spindle setups. Make sure you got this eccentric mark in between these two bolts right here. You want to Loctite, make sure it's clean. You want to clean it up inside and out. Put 3 to 4 drops of 680 Loctite on there. Put it back on in there, same way. Get it lined up. Make sure that your split is to the top. Lock it down using your star pattern. 20 pounds all the way around. Smack it with a brass hammer. Make sure it's centered up. Make sure it's locked tight. 30 pounds, 40 pounds around. Do the same thing. 65 pounds. Give it a smack with the brass and a hammer. Make sure nothing moves. Check it again with your torque wrench. And you're off to the races.